Hey guys, welcome back to my channel, TheTalk. Today we are going to start with the 1.3 of the real numbers. So this deals with the theorem of fundamental theorem of arithmetic. First let's look at the theorem. And what does the theorem say? That every composite number can be expressed or factorized as product of primes, and this factorization is always unique apart from the order in which the prime factors occur. So let us first see what is a composite number. A composite number is a number that is having factors more than one and number itself. So if it has factors more than 1 and the number itself, we call it as a composite number. And every composite number can of course be expressed as product of prime numbers, and it says that this factorization is unique apart from the order in which the prime factors occurs. We will look at the explanation of this in the next step. So it means that prime factorization of any number is always unique, and it says that of course if we consider one number as let's say 15. So 15 can be expressed in the factors of 5 multiplied by 3. So this can also be written as 3 multiplied by 5. So even though the numbers have been jumbled, like 3 multiplied by 5, the places have been changed, but the product remains same. So 15 is the product always. So that is what the theorem explains. That even though you change the order of the number, that means whenever they are multiplied in any order, the prime factorization of the number is always unique. I have taken an example. So 20 I have expressed in the form of prime factors. So generally we can consider this method of LCM to find out. So 2 divides it 10 times and 2 times 5. So 2, 5 and 2 are the prime factors. So it can be like 5 multiplied by 2 multiplied by 2. Or 2 multiplied by 2 multiplied by 5. So this would be also giving 20. This is also 20. And 2 multiplied by 5 multiplied by 2 also 20. So this nothing but this even verifies the commutative property of multiplication. So that says that the numbers can be multiplied in any order whenever you multiply. But the factors, the prime factors are always same. Okay, only thing is the order changes. So that is what the fundamental theorem of arithmetic tells us. So moving on, how to find HCF and LCM of the numbers. So we will consider an example first. HCF of 6 and 20. So before you find HCF of anything, the first thing that you have to do is find the prime factorization of it. So when you express 6 in the terms of prime factors 2 and 3, so this can be written as, so 6, you consider the prime factors of 6. 6 is 2 multiplied by 3. Then let's consider 20. So yes, so 20, 2 multiplied by 2 multiplied by 5. And here is a statement that says HCF is the product of the smallest power of each common prime factor in the numbers. So let us see how this statement will be verified now. So to consider HCF, okay, so HCF, which means highest common factor. So we did the first step, we could find the factors of the number. So this is done. Next, let's look at the common terms. So when you consider 6 and 20, the common factors are 2 over here, and in 20 also, like they both are having one common factor, that is 2. So we got the common factor also, 2 is the common factor, and which is the highest among them? So if you look there, 2 is the only highest common factor because 2 is the only common factor, so 2 is the highest common factor. So now you can say that HCF of both these numbers. So HCF of 6 and 20 is 2. So that's how you do. Like you start from the right side. You find the factors first, then the common factors, and then the highest common in that. So it says HCF is the product of smallest power of each common prime factor. So that is what we did, right? This is 2 power 1 and this is also 3 power 1. This is 2 squared multiplied by 5. So they say the smallest power of common prime factor. So first you have to find out the common prime factor, which is common, 2 is in common. And what is the least power? 1. So 2. 2 is the smallest common prime factor. So that is the HCF. And now to find out the LCM of two numbers. Similarly, just as HCF says highest common factor, LCM means least common multiple. So let us see how we calculate the LCM of these numbers now. So even for the LCM, we consider the prime factors. We know that 6 has prime factors as 2 multiplied by 3 and 20 has the prime factors of 2 multiplied by 5. So LCM is quite opposite of HCF. So in HCF what we did the product of the smallest power. So smallest power was only considered. Whereas in LCM we consider the product of the highest power. So this is 2 square multiplied by. Now if you consider the LCM, so highest powers, that is 2 square, then 3, then 5. So it is nothing but multiplying all the numbers, but whatever number is in common, like multiple, you have taken all the factors and then whatever numbers are in common are taken, but what you will do is you will multiply the power with the highest power will be multiplied. So that is how you find the LCM of the numbers. And now we have found out that HCF of these two numbers 6 and 20 we got it as 2, and LCM of these two numbers we got it as, so LCM of these two numbers 6 and 20 we got it as so LCM of these two numbers 6 and 20, LCM of these two numbers 6 and 20 we got it as 60. So if you verify this, HCF of A and B, that is 6 and 20. So HCF of two numbers 6 and 20 multiplied with the LCM is nothing but the product of two numbers. So that is what this formula tells us. So this helps us in following. Find the HCF of 96 and 404 by prime factorization. Hence find their LCM. So we have been given two numbers 96 and 404. So let's consider 96 when we do the prime factorization for this. Let's do step by step, starting with 2. 2 4s are 8, 2 8s are 16, 2 2s are 4, 2 4s are 8, 2 12s are 24, 2 6s are 12, 2 3s are 6. So this is nothing but 2 power 5 multiplied by 3. Now in the same way we have to do the prime factors for 404. So 2 times 202 and then 2 times 101. So this cannot be factorized further because this is a prime number. Now 404 can be written in the form of prime factors as 2 square multiplied by 101. And remember in the previous slide we discussed that HCF multiplied by LCM of any two numbers is the product of two numbers, right? So LCM of 96, 404 multiplied by HCF of 96 multiplied by 404 is nothing but the product of numbers, that is 96 multiplied by 404. So we are asked to find its LCM, right? So but before that we are supposed to find the HCF of both of these numbers. So if you look here, like what are we supposed to do? We are supposed to find the lowest power, number with the lowest power, that is like even if you consider the factors, let us see. So 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 2. So this is nothing but 2 multiplied by 2 multiplied by 101. Now you have expressed in the term of prime factors and then the common. So only this 2 and this 2 is common, this 2 and this 2 is common. So the highest common in these both is 2 square, that is nothing but 4. So HCF is 4 of 96 and 404. So if you substitute in this equation, LCM of 96, 404, that will be becoming equal to 4, 96 multiplied by 404. So now when you send this 4 to the other side, when after transposition, then this becomes 96 multiplied by 404 equals to 96 multiplied by 401 divided by 4. So upon simplification, 101. So when you multiply this, you will be getting the answer as 9696. So this is how you can apply the formula that LCM of two numbers multiplied by HCM of any two numbers is the product of the two numbers that you are considering. So that's all for today's video. So we will be starting with the exercise problems of the next basing on these prime factorization in the next video. So if you like the video, please don't forget to like, share and subscribe to our channel, TheTalk. Bye-bye.